Okay, so welcome back. And today in this lab session, we will go over some of the basics of the ROS Python API that we covered in the accompanying lecture video. And in particular, the goal of this lab session is to make you familiar with and comfortable in working with actual ROS nodes. So far, we've only run some nodes and played around with the topics and messages. But today you will get your first glimpse at the actual code inside a ROS node and how do we initialize a piece of Python executable as a ROS node, and then how does a ROS node in turn can be set to publish or subscribe to a particular topic. So this is a bit of a continuation from where we left things in the previous lab session. So if you haven't finished or completed the previous lab session, you should go and watch that video as well to make a more sense of where we are starting from in this video. So as you can see on my screen, I already have ROS core running in the background. And just to quickly refresh your memory, previously what we had done is we had created a package called beginner tutorials, and then we had made a GitHub directory. So if I go to GitHub in my home page, my home folder, you see there's this F1tenth course labs is the GitHub directory that we had copied from the GitHub tutorial, and the steps for this were covered in the previous lab session. So I hope you all followed along and you have this directory on your VM or Ubuntu session as well. And then what we had done was, let me go to my Catkin workspace. In that workspace, we created this workspace, and in this workspace, if we go to the source folder, there is our package called beginner tutorials, and we copied the contents of the F110 course labs into beginner tutorials. So if you go into the beginner tutorials subdirectory, which is the package, you should see something like this. And we even ran catkin make previously to make sure everything compiles. So essentially what we have done till now is we have created a package. Remember how we also specified the dependencies of this package last time on a bunch of different things, one of which was the rospy or the ROS Python API, which is what we will use today. And inside this package, you have many folders. Today, we'll be mostly concerned with what's inside the scripts folder. And you can also add all of these in the source folder. The reason why source and scripts are two different subdirectories is because typically I use the source folder for C++ nodes and scripts for all Python nodes. So that's just a personal preference. This is not a requirement by ROS or anything. So today we will get to experiment and tinker around with some of the nodes inside our beginner tutorial package. So make sure you have the beginner tutorials looking exactly like this. And once again, it's already something that we covered in the previous lab. So if you don't have your beginner tutorials package look exactly like what you see on the screen here, you should go and follow those steps and make sure you also then build the Catkin workspace after copying over the contents from the GitHub. So for the time being, let's just clear everything and we can get started with our tutorial. And so if you recall, in the previous lab session and also in the lecture, I showed you this simple publisher and subscriber setup called talker and listener.python, right? So let's run both of these nodes to get a sense for what is going on before we look at the code. So I'm going to start my first node, and since I have already sourced my environment and added the path to the setup.bash in my bashrc file for the Catkin workspace, as soon as I start typing beginner tutorials, ROS already knows how to find my custom package because it has been sourced properly in the shell. So the first node we want to launch is rosrun. Name of the package is beginner tutorial and the node name is talker.python. And when you hit the return key, you can see it's echoing messages called hello world with some number, which is like a ROS timestamp. And that's all it is doing. And we'll see in the code how it is just set up to publish this hello world message repeatedly. So it's publishing this message, and already we can kind of inspect where it is publishing this message. I can say ROS topic list first to look at the list of all the topics, and we see there's a topic called chatter, which is where these messages are getting published. So who is subscribing to chatter? Right now there's no other node. In fact, the only node running right now besides the default logging nodes is the talker itself. So let's run our listener, which will subscribe to these messages. And so to do that, we can say ROS run, again, beginner tutorials, which is this package name. And this time we will launch a node called listener.python. And so when we launch listener, you can see listener itself is telling us that I heard some hello world message at some timestamp. And if we now go and look at the ROS node list again, we have listener. And notice, first of all, how I ran the node listener.py, but the name of the node is listener, and it's appended by some pseudo random sequence. And I'll tell you why that's the case by the end of this lab session as well. But now we have two nodes. We have a talker and a listener. And if we want to really confirm how they are connected, we already know they are connected through the topic chatter, on which the talker is publishing hello world messages. And as soon as the listener gets that message, it's simply acknowledging that I heard the hello world message at that timestamp. So there should be like a one-to-one correspondence between the two. But nonetheless, this is a good opportunity to use another tool called Rqt Graph, if you remember. We've used it many, many times. And so if you run Rqt Graph with ROS run, we should see a simple computation graph where we have the talker, which is running in this window on the bottom left. It's publishing on a topic called chatter, which we have also confirmed. And the arrow directed edge shows that the listener with this appended pseudo-random sequence of numbers is subscribing to the chatter topic. And so this is how data is being sent from the talker through this topic called chatter to another node called listener. And so just keep all of this in mind as we start looking at the nodes, because now this is a very basic publishing and subscribing model. It's one publisher, one subscriber, and one topic. But this is where we will begin our investigation of how to set up the Python scripts talker.py and listener.py and what is going on, which is making all of this work as expected. So let me close everything before jumping into the code itself. And again, I just like to clear all the sessions. And for this next bit, we don't even need ROS code running. So I'm going to stop that too, just so that my VM has less work to do. Okay, so let's start looking at the code itself. And so we will use some ROS file system tools that we have discussed before to navigate our way faster to where we want to go. So what I'm going to write is ROS CD. I want to change directory to the package beginner tutorials. And I already know that the subdirectory is called scripts. So in a single command, I can change my current working directory to where I need to go. And this is where the executable Python scripts reside. So this is what we were running when I just showed you the example. So let's maybe start by opening up talker.py, and you can use your favorite editor. I'm just using Atom. You can use gedit, vi, whatever you prefer. So let's go over what is this script doing and how is it publishing these hello world messages on the chatter topic. So right up top at the very beginning, the first line is this: every Python ROS node will have this declaration at the top. This first line is just making sure that the script is executed as a Python script. So we have to always include, this is not just like a comment, because this hashtag symbol is also used for commenting, but it is a requirement for ROS to know that this is a Python executable. Then we can skip the comments. It's just telling us a little bit about the node itself. The node is called talker.python, the name of the file. And next, the line of interest is we are importing the ROS Python API library. So we need to import ROS Python if we are writing a ROS node using Python. And then the standard messages dot message, this import is so that we can reuse a message type called string for constructing a message that we will publish on this chatter topic. So we need to import the message type string from this library called standard messages. And there are many such libraries. We also saw another library called geometry messages, remember, in the Total Sim days. And so standard message is just another available library when you download ROS. Then let's look at what is going on in the code itself. So we can look at the main part of the Python program. And here, what is happening is we are saying you have the standard Python main check. So I hope you guys are familiar with that. But what is happening inside this is it's trying to catch some kind of an interruption or an exception, which can be thrown if the node doesn't sleep for enough time. I'll talk about what sleep means over here. Or exception is thrown when you press Control-C and the node stops executing. We need to exit the execution of the program. So that's what this snippet of code does. But what mainly it is doing, it is calling this function, which is the main, which is the critical part of the code called talker. And so all the interesting stuff in this node is happening in this function called talker. And here is where we are actually initializing the node and declaring a publisher. So let's go over everything in this talker function one line at a time, starting with the very first line over here. So this section of code essentially is defining the talker's interface to the rest of ROS. Okay, so far we've just imported the libraries, but ROS has no way of knowing that this executable called talker.python is a ROS node yet, right? So what you see here is this line, the handle pub equals rospy.publisher with all these arguments. This essentially declares that this node is publishing to the topic chatter using the message type string and using a queue length or a queue size of type 10, right? So how does ROS know what string is? Because we just imported that from as a dependency in the node. We can define the name of the topic. The name of the topic is chatter, and what we are creating is a handle to the ROS Python API using the functionality rospython.publisher. And so recall from the lecture that the arguments are name of topic, type of message allowed on that topic, and optionally specifying the queue size. If you don't specify the queue size, it takes some default value. Right, so the queue size in a nutshell is it limits the amount of messages if any subscriber is not receiving them fast enough. Right, so that's what that's the use of the queue size, but we don't want to get bogged down by this detail quite yet. It'll become relevant when we actually have many different publishers and subscribers. So that's what the first line does. It's just creating a publisher. The second line is actually even more important because the next line tells the rospy API the name of this node. And until this API or ROS Python has this information, it cannot start communicating with the ROS master. So remember how in the very beginning I said when you create a node, it registers itself with the ROS master. So that's happening because of this piece of code called rospy.init node. And it takes two arguments in this case. The first is the name of the node, which is talker. It's a good idea to name the node the same name as your executable script. And then it takes another argument called anonymous equals false, which we will get to a little bit later. So the main focus right now is that the rospy.init underscore node followed by the name of the node is very important for this piece of code to be declared as a ROS node and to communicate with the ROS master. So in this case, our node will take on the name talker. and that's what it will appear in the ROS node list as we just saw a minute ago. Then let's go to the next line. This is a little bit more intuitive. We are specifying a rate object called rate, all spelled in lowercase. So rate is a rospy rate object. And what it does is, with the help of the sleep argument, it maintains a certain number of messages or frequency of the publication that we want this node to do. So it's a convenient way for looping at some desired rate. In this case, we have the argument of 10. So what we expect is that we should go through this entire loop of the publisher at 10 hertz or 10 times per second. Now notice that while we can put any number here, there needs to be some thought given to what this number needs to be, because if the execution time of this code is more than 1/10 of a second, we will not be able to maintain this rate, right? So by providing some rate value, we are also saying that we expect all the computation of this node to be completed in less than 1/10 of a second in this case. So that's what rate does. It tells rospy at what rate to publish messages on Chatter. But what are these messages itself, right? So that happens in this section of the code itself. So this loop is a fairly standard way to do publications with rospy. And so let's look at what is happening. First, we say we are checking the rospy is shut down flag. Okay, so this flag is again set if there is a control C or for whatever reason the node stops execution, then this flag will be set. So what we are saying is, as long as this flag is not set, so while not rospy is shut down, in this case, what we are doing is we are creating a string called hello_str. And so this string is nothing but hello world, and then it uses the rospy get time function to append the message as part of the string itself with the value of the time at the time this message is created. Okay, so rospy get time is just adding that sequence of numbers at every message so we can timestamp them. And by the way, we will inspect the notion of time in ROS as a separate topic in this course as well. So right now, this is more of just telling you how to get that function or that value in, rather than explaining how it works. So we created our string, and then what we do is we also call, this loop is also calling something called rospy log info, and this is performing multiple duties or multiple tasks. The first is that the messages that you pass to rospy.loginfo, they will get printed on the screen. They will get echoed on the screen, which is what we saw when we ran this node, that we had a bunch of hello world followed by this time value appear on the screen at 10 hertz. And so that's one of the things. The second thing is this value is also getting written to this node's log file. So remember how we have some default logout nodes which are also started when ROS master starts. Well, if you pass arguments to loginfo, in this case we are passing our string itself, it's also getting logged as part of that node's log file. And so it gets written to the log file to ROS out, and later we can pull up these messages for debugging. Then this command is where the actual publication takes place. So what we are saying here is using the handle that we created. So pub was the handle to the rospy publisher, which already knows what topic to publish stuff on and what is the message type. Here is where we actually publish the message to the topic using this command, the handle and the .publish function within the handle. So we can say pub.publish, and then we pass the message. This message must be of the type string, otherwise ROS will complain, because it will internally check whether the data type of what you are passing matches with what the publisher channel has been set up for. And then finally, there is this function called rate sleep. And so this loop is calling rate sleep, loop being this part. It is calling rate sleep, which is essentially ensuring that this node sleeps just long enough to maintain the desired rate through the loop. So remember, we want to publish the messages at 10 hertz, and we don't have to worry about publishing this uniformly 10 times a second. ROS is taking care of that by just calling this function rate sleep. So essentially, it is in between two different messages which are published. The node is just automatically calculating how much do I have to go into sleep, where I'm still executing. I haven't ended my execution. The node is still alive, but I wake up and then publish again and I go to sleep, and all that you don't have to figure out and compute the time in milliseconds and whatnot. You simply specify the rate and call rate sleep, and the node will be alive, and it will maintain as much as possible the desired rate that you want through the loop. So that's mostly it. That's what this talker.python is doing, and I hope this clarifies a lot of different things that we have discussed in the lecture, and we have been building up to the publisher and subscriber model in the previous lab sessions as well. And so the main things to keep note of are, this is very important line to initialize the node. You have to tell the name of the node, and I promise I will explain what anonymous argument does in just a second. And then you, depending upon what the node has to do, in this case it's a publisher, so we use the rospython publisher API to initialize a handle to the publisher. Another thing that we will use a lot from the rospython API is the rospy.rate function. Then you need to get used to using this style of writing the loop, where you are running this as long as there is no shutdown flag. Get time is not that critical function that we will use that often, but you can still keep note of it. Rospy.loginfo does many things. I hope that's clear too. And then you actually publish the message using pub.publish followed by the entire message itself. In fact, there's many ways to publish. This is not the only way, but this is the most easiest way. And then rate sleep takes care of the execution cycle and the rate at which we are publishing messages over here. So let's now close this and jump to the listener.python. Okay, so let me scroll. Yep. So by the way, listener.python also has the same declaration up top. So every ROS node in Python needs to have that. And we can just skip all the comments over here and directly get to the code part. So let's go over what is happening in the listener.python. So firstly, you will notice some things are very similar. We also import the rospython API. We are also importing the message type, because this node also needs to know what a string is, or what is the definition of the message type string. And then in the main Python call, in the main part of the function, we are just calling the function listener. So most of the stuff is just happening in this function right here. So let's see what this does. It's even more simpler than the talker.python. So essentially, we are first initializing the node itself. So the name of the node is listener. But in this case, when we also initialize the node, notice how the second argument, anonymous, is set to be true here, whereas it was it was set to be false for the talker. So let me spend some time to explain what this argument does and why is it useful. So essentially what it does is this anonymous equal to true keyword. In ROS, you require that every node has a unique name. So you cannot have two nodes which have the same name. In fact, I will show you in a second that if you have a node running and then you instantiate that same node again, right? So if we have our talker.python running and we start another instance of talker.python, the first one will automatically stop running, right? It will kind of bump the previous one. So this is so that this is like an inbuilt capability or a fail-safe in ROS. So any nodes which are not behaving properly can be kicked off this, can be deregistered from the ROS master. So the anonymous equals true argument is telling the ROS Python API that when you create the node, use the node name provided, but create a unique name for the node so that we can have multiple instances of the listener.python without worrying about one instance blocking the execution of the other. So this is why when we saw the name of the node in the Rqt graph and also in the ROS node list, we saw the listener was not just called the listener, it was listener appended by some random sequence of numbers. So that's where this is coming from, because the argument anonymous was set to be true, and all this was ensuring was that if I launch a bunch of listeners in different terminal sessions, they will not interfere with the operation of the other instances of that listener, because each of them has a unique name, even though it's using the exact same code over here. And I will show you this after we have gone through the code. I'll show you this in the actual execution. But that's the use of this argument anonymous equals true. So now we know what is going on. We initialize this and we call this as a listener, so it can register itself with the ROS master. And then we are saying that this node is a subscriber. Notice that we don't need a handle to the subscriber, unlike with the publisher. And so all this is saying is this node is a subscriber. It is subscribing to the topic chatter, the same as the one on which the talker was publishing. On chatter, we expect messages of the type string to arrive. And for every message that arrives on the topic chatter, this subscriber will call this callback function to parse and process each of those messages. And we'll see what the callback does. But see how there is no while one loop here. There's no shutdown flag or any of that stuff that we saw in the publication. So all this node is, it's literally a listener, right? So it's listening to the topic chatter. For every message hello world which arrives on chatter, we will use the callback function to parse that message and do whatever we want to do with that. But what is keeping this node from not ending after one execution, right? This is also being kept alive. So we again use, rospy spin over here. So spin is similar to sleep. The sleep, to run rospy sleep, you need to define the rate object. But for a subscriber, the rate doesn't make sense because we have no control over the rate. We can only listen to the publications and the messages, which so the publisher is the one which needs to use the rate object. The subscriber just needs to wait patiently until a message arrives on this topic and then process it. So to keep this node from exiting until it has been shut down, we use rospy.spin. Okay, so that's the equivalent of keeping your node alive from a subscriber, and you will use if this node is a subscriber, and we can use rospy.spin very often. So the last thing which remains to be discussed is what is happening in the callback itself. So as soon as a message arrives, we go to the callback function, we load the contents of the message into this variable called data, and then we are calling loginfo again. So again, loginfo is doing all those 2-3 things, and what we are asking it to print out is rospy caller ID. So this is going to be the name of the node, because the name of the node is going to be listener and then the number itself. And that's not the important part anyways. The important part is it's printing out, I heard the contents of this message. And this is where I want to draw your attention, because this might be confusing when you look at it on first glance. Remember that we already know that we are getting some strings on this topic called chatter. And for each of those strings, I'm using the variable data or the structure data to load the value of that string. And now to print that out, to print the actual contents of the string out, notice how I'm calling a subfield of my structure, which is data, dot data. So you may be confused why this is happening. Why is this data dot data and not just data itself? I hope that question itself makes some sense. So let me show you what is happening. Let's keep this on the top, and first we will use one of the ROS file system command line tools to look at the standard message library. So let's say we say, and hopefully you recall what I'm writing. I'm going to say rospack. Remember how we used rospack find, and I want to find standard messages. Okay, so it's in this directory, so I know it exists. So now I can just cd to standard messages, and let's see what are the contents of this standard messages library. So sure enough, there's a subdirectory called message. So let's look at message, and you can see this is where the corresponding message type for each of the standard messages supported message types is stored. And sure enough, there is something called string.message. Now in our lecture, we haven't covered message directories yet. That's one of the last things that we will look at in the learning ROS module of this course. But I'm going to show you this file anyways, right? So I'm going to, let's say, open this file called string.message, and oops, here is that file. That file just has a single field called data of the message of the type string. So the contents of the publisher are stored in this field of this message structure, right? So this is the string.message structure, and it has only one field called data, which is why the first data in this call is my own handle. So I could have called it, let's say, something else. I could have called it packet, and then this would have become packet.data. The dot data is coming from the fact that the message type has a field called data, and I need to know that in order to parse the message correctly. Okay, so I hope that makes sense in terms of clarifying why we are using this seemingly confusing data.data. It's just so that the first data is just a misnomer, right? It could have been called something else. The confusion arises because it is also being called data. But I hope you get the idea. So in a nutshell, the subscriber is just listening to the topic chatter, and for every message which arrives on chatter, it is using this callback function to print out I heard hello message, and then there was the timestamp as well. So with that, I hope you now understand some basics of the ROS Python API on how to create the publishers and the subscribers. how to keep your node alive, and how the callback function uses the correct message type in order to parse some of these messages. So with that, let me quickly go back to demo mode and show you the implication of the anonymous equals true and false. So let's close all of this, and it helps to just always be in the home directory. So let's start roscore. And once again, I'm going to start my Docker, ros run beginner tutorials docker.python. So now you know exactly what is the reason for all these messages to appear. It's the rospy loginfo part of the publisher, which is echoing all these messages. This is the rospy get time, which is appended to the message itself in form of a string. Then we can start our listener. So I can say roslan beginner tutorials listener.python. And sure enough, now you see this was the first part of the message where it said get node ID. So it's just the name of the listener. And then the actual message is I heard hello world and the same timestamp and the same time as part of the actual message. Remember, this time is being received from the publisher. The subscriber is not adding its own time to the message. So this is good. Let me also open Rqt Graph so we can visually see what is happening. Rqt Graph. And let me just keep this always visible. And now I'm going to run another instance of the listener. So the listener is already running, but there's nothing stopping me from running this command again. So when I run this, first you will see how the ID of this listener is different from the ID of the listener above. And if we just refresh our node graph, we can see we have two instances of listener. And both of them are subscribing to the topic chatter, which is being published by the talker. And the reason why Ross is not complaining about running two listeners in parallel is because they have different names. The node names are unique. And they are unique because we are using the anonymous equals true flag in the declaration of the rospy.init node. But what happens if I try to launch another talker? So let me create room for that. And here, above this, a talker is already running, as you can also see in the Rqt graph. But now I'm going to say ros run beginner tutorial, and I want to launch another talker.python. And if you remember, in the talker.python publisher code, the anonymous was set to false. So before I hit enter, try to guess, what will happen. Will we get an error and everything will crash? Or will Ross be smart enough to realize this is a different talker and maybe create a unique name, or maybe something else, right? So try to guess what will happen. Of course, if you are following along, you can already hit enter and see for yourself. But let me do that for you, right? So when I launch this talker, you can see I get a bunch of messages. First, I have a shutdown request automatically received from my previous instance of the talker. So it says that it's shutting down this talker instance because the reason is there's a new node registered with the same name, right? So, and the same thing is being sent here, that a new node is being registered with the same name. And so now there is no talker anymore. And it also says, it's raising that exception. Remember how in the publisher we had some exception where it was we had this try and catch function in the main part of our Python code. That's also being shown here. There was an exception because it couldn't register the new instance of the node before the previous instance was ended. So now if I try again, this time it should work because the previous instance has ended. And if I refresh, we are back to sort of square one. Although this is a new process executing the same code, the previous one has ended. And the exception again was because it couldn't register the new instance. Like you may be thinking that why was an exception thrown? Why didn't the new talker just launch from the, why didn't it launch instantly and threw an exception? The exception was that before it could register itself with the ROS master, there was already a talker in the system. So that's why it wasn't happy. But now we know that the previous talker was shut down by ROS master. The new talker can run. And so we are back to our previous configuration. So all of this was just to show the implication of the anonymous equals true flag. Okay, so let me close this. And then let me show you one more thing. We can say ROS topic list. So as we already know, there's only one topic of interest called chatter. And here I want to show you, if you recall, we had gone through this command, ROS topic hertz, and then the name is chatter. I want to see at what frequency is the chatter, our messages on chatter being published. And you can see that the average rate is 10 hertz, which is exactly what we have configured in our publisher. So the number of subscribers does not change the rate of publishing, right? That's another obvious thing, but I think it just helps to clear that up. The number of subscribers doesn't change the publication rate. The rate of publication remains the same as has been specified in the in the publisher code, and as many subscribers as possible can be launched which are listening to that single message. Okay, so that in a nutshell is an overview of the ROS Python API, especially as it pertains to initializing nodes, initializing a publisher, and initializing a subscriber. To conclude this lab session, I will show you another example of a different type of publishing and subscribing setup. So let me clear all this up and resume once I have the other setup ready. So for this example, I already have ROScore running as well. And in the code that you have copied from GitHub into the beginner tutorial package as part of your Catkin workspace, there are a few other nodes as well. I think one of them is a good example of how you can have both a publisher and a subscriber as part of the same node, right? So that's something we haven't seen yet. So to show you that, let's just change directory into our beginner tutorial scripts again. And if I show you the contents of this, we have two nodes of interest. So the first is what is called randomnumber.python, and the other is publisher and subscriber.python. So let me show you quickly first the code for both of these to tell you what is different about these nodes as compared to our simple listener and talker, and then we'll run them and see, if it works as expected. So let's first look at randomnumber.python. So I'm just going to open that up. Yeah, so this is not that well documented, but it's easy to follow. And this by now is clear. We already need this declaration and importing the ROS Python API. This time I'm importing from standard messages a message of a 32-bit integer, right? So I'm importing this particular message type called int32. From the random library, I'm also importing something called random integer. And so So these are all the dependencies of this random number dot Python. So in the main part of this function, we are initializing the node. So already this is different because earlier we used to initialize the nodes as part of the functions and not the main part of the Python executable itself, but it is allowed, right? It's not forbidden. You can initialize the node here as well, rather than having a separate function. Basically, we've replaced the function with the actual code itself. So we initialize a node called random number, and that's the name of the node. We don't care about the anonymous argument here. By the way, I think by default, if you don't set the anonymous, it's set to false. Okay, so just be wary of that. Then we create our handle to a publisher. We know what this means. The topic we want to publish messages to is called rand_no. It will publish 32-bit integers with a certain queue size and at a certain rate. So we created a rate object as well. And here is our main kind of the main loop. So since this is a publisher, which is seen here, we use this is shut down flag to set up a loop. And since we also have a rate object, we will use a rate sleep to maintain the execution of our node. So what is happening in this loop? As long as everything is fine and the node isn't shut down, we create a random number called rnd_gen. So we generate a random number by calling this function, generate random number. This function is right here. It's very, very straightforward. It just calls rand init, which is this function that we imported, and it returns a random number between 0 and 5,000, a random integer to be specific, between 0 and 5,000. So this number is returned and assigned to this variable rnd_gen. Then there's a simple if-else statement. What we are checking is if the random generated number is less than or equal to 2,500, then you echo this message that the number is lower than 2,500 and you display the number itself, and then you publish the number, right? So we are just publishing this 32-bit integer because that's what this function returns, and so this is compatible with the requirements of our publisher. So this command will publish the number on the topic rand_no. Excuse me. And then we say, well, if you are greater than 2,500, then you still publish. So in either case, you are publishing. But for the sake of understanding this example, you also echo that the number is higher than 2,500. Okay, so it's a very basic, simple publisher. It's no different than Talker, except that instead of strings, it's publishing random numbers. So we import whatever is needed for that to work. Okay, so I hope this is clear. And the interesting part is then, who is subscribing to this random number topic. And so as you may have guessed, that is in this node called publisher and subscriber. So let's open that up. And so here we have the same sort of dependencies, which makes sense. They are imported. And so let's get started with the main function, and then that will be a good way to understand what this node does. So this node is called pub and sub. Why is it called that? Because it is both a subscriber and a publisher, right? So that's why I wanted to show you this example, that a single node, the node is just pub and sub. It can do both subscribing and publishing, right? So it's not always the case that every node is either a subscriber or a publisher. So we first declare our handle to the subscriber, and this is not necessary because we don't use this handle, but it is not incorrect either. In the previous listener, we specifically weren't using this handle. So anyways, we use the subscriber or declare the subscriber using the RosPython API. So the arguments are the topic we are subscribing to. This is what the random number.python was publishing to. The messages we expect to receive are of the form integer 32, and for every message we receive, which is the value of the random number, we are calling a callback function. So what is this callback function? This function is defined here. The contents of the message are stored in this structure called MSG. We use a global variable called variable S, and it's called variable S because this is the variable which stores the value that the subscriber has received. It's VAR S. S is denoting the subscriber or the inflow of the data. And so this variable is assigned the value of the field which actually stores the random integer. That would be data itself, and you can convince yourself again that the integer 32.message file has a single field of the type int32, and the name of the field is data, which is like a standard way in many ROS messages. That's why you don't have to check it every time, but it's a good practice to take a peek at the message at least once. So what has happened is, for every random number we receive on this topic, we are calling fallback and assigning that number to this global variable called VARS. Then we also declare a handle to a publisher. And this publisher is publishing on a topic called sub_pub. It's also publishing a 32-bit integer with a queue size of just 1. And we are publishing at a rate of 10 Hertz. But what are we actually publishing? In our main loop, we say if the value of the integer that you received from the random integer.python, the previous publisher, if this value is less than 2500, then you assign another variable called VARP, P denoting the publishing side of things. You assign it a value 0, and if it is greater than 2500, you assign it a value 1. And then you publish the value of VARP. And we use rate sleep to maintain this node, keep this node alive. So just so that you understand a few things. From the publication perspective, this code is exactly what a publisher does, right? We assign a handle, assign a rate, check for shutdown, do our stuff, and publish stuff, and then call rate sleep. But this node is also a subscriber, so periodically it will also get triggered every time there's a new data available on random number, and then this execution will take place. And because this is a subscriber, we are not using rospy spin here because we're already using the rate.sleep. So you don't need to use both, is the first thing that I want you to remember, because you will write nodes which have publishers and subscribers, and if you are unnecessarily causing your node to spin and consume cycles and go to sleep, it sometimes breaks things. So just be mindful of that you only need, as long as you have a publisher, the publisher way of keeping a node alive works. If you only have a subscriber, then you need spinning, the rospy.spin that we were using in the listener.python. So in a nutshell, what you can expect to happen is, from the previous node, the random number.python, it will echo its own messages. The number was greater than 2500 or less than 2500, but it's publishing on this topic, random number. This node is subscribing to that topic, and based on whether the value it receives is less than or greater than 2500 again, it is assigning a new variable a value 0 and 1 and publishing that variable on its own topic. So it's subscribing to another topic and publishing to its own topic. And what we should be able to see is, whenever the random number generated was less than 2500, we see a 0 on this topic. And whenever it was greater than 2500, we see a 1 on this topic. Okay, so this is all just to give you the intuition for what you expect. So now let's quickly run these and confirm if they work as intended. Okay, so let me first run the random number. So we say rosrun beginner tutorials, and the name of the node is random number.python. And you can see that it's very, very fast, but you can see it's for every random number it generates, it says the number is higher or lower than 2500. And that's the message it was printing in the simple random number, which is just a publisher. Then here I can say, let's run the other node. So ROS run beginner tutorials, and we run the node publication and subscriber, publisher and subscriber.python. And this node runs, but interestingly enough, it doesn't echo anything. So let me quickly show you why that is the case, or I should just relaunch from this window. We don't see anything on the screen because we are not using rospy, the loginfo function, right? That was the function which is responsible for sending messages to the shell. So it is running because we didn't get any errors, but we don't see the messages quite yet. So where are those messages? They are all in a topic, right? So let's look at the list of, well, let's first look at the list of nodes. So sure enough, we have two nodes, the random number, which is running here, and the publisher and subscriber running just above this. Then let's look at list of topics, ROS topic list. So we have two topics of interest. The first is random number, which is the topic on which the random number.python is publishing the value of each of the random numbers. This node is subscribing to random number, doing this variable s and variable p transformation from the number to 0 and 1. And that 0 and 1 value is published on this topic, subscriber publisher. So now if I run ROS topic echo, I want to see the messages being published on subscriber underscore publisher. I should see the zeros and ones corresponding to whether or not the number received from the random integer is less than or greater than 2500. And I know this is too fast to do like a one-to-one correspondence, and maybe as an exercise, try to reduce the rate to 1 Hertz from 10 Hertz and things like that, so that you can actually see that the data, which is 0 and 1, is correct. So this was an example to just show you an example of a node where you can both publish and subscribe to different topics in the same node. And for sanity check, we should always just quickly check out the Rqt graph of things. Rqt graph, Rqt graph. And sure enough, this is what is happening. We have the random number.python publishing the actual value of the number generated on the topic rand underscore no. This topic is subscribed by our publisher and subscriber. Inside that, you already know it's doing this callback where it assigns this to a global variable called vars. Then it has a if-else statement to see if the value of vars is less than or greater than 2500. Based on that, it assigns a value of 0 and 1 to another variable called varp, publishes that variable on a topic subscriber publisher. And this node is our ROS topic echo, right? So it doesn't really, it's not its own executable. It's here because to echo the messages, ROS has created this own temporary ROS topic node. Okay, so I hope with all of what we have learned today, you have some very good understanding of the ROS Python API, how to initialize nodes, the role of rate objects and sleep when it comes to publishing, and the role of rospy spin when it comes to subscribing. And then when you do this enough times, you will get to know a lot more about the different message types and their fields as well. In fact, one of the next lectures is going to be on messages and services in ROS. So with that, we come to the end of this lab session on the ROS Python API, and we will resume our understanding ROS beginner tutorials into next week. And by the end of next week, we'll be ready to have our first shot at an assignment where you will write your own nodes to do some very interesting things with the turtle sim simulator. So stay tuned for that, and I will see you next time.